Hello and welcome everyone to the podcast series Voices of Innovation Shaping the Future of Tech Education. I am your host Dr. Jyoti Tripathi, Assistant Professor in the School of Computer Science and Engineering at IIM University Gurugram. Today's episode in the series is going to be very exciting since we are diving in the topic of role of mathematics in computer science in engineering. To have this conversation ahead, we have our guest Dr. Shagun Panghal. Dr. Shagun Panghal serving as Assistant Professor in the School of Computer Science and Engineering at IIM University Gurugram. Dr. Shagun has done his PhD from MNNIT Allahabad and has specialization in the field of numerical techniques and artificial neural networks. Dr. Shagun, we are honored to have you here as this guest for this podcast.
Thank you so much, ma'am, for welcoming me and for such a warm introduction.
So, sir, the first thing thinking about this topic, the first thing that comes to my mind, why math is so important to computer science?
I think, ma'am, that's a great question to start with, and I would like to answer this without going into any computer science or mathematical technicalities. So the thing is that coding is the preferred mode of engineers for communicating with the computer. But without mathematical logic and without mathematical strategies, it is difficult to give instructions to the computer. So what happens is, when we are able to think mathematically or with mathematical thinking, we are able to give precise, concrete and sequential instructions to a computer that removes ambiguity and make us our work very easy and easy to code and everything related to that.
Okay, got it, sir. So, how does this mathematical ability actually help a computer science engineer in doing their day-to-day job?
Okay, there are so many ways in which mathematical thinking or mathematical abilities can help a computer science engineer. Firstly, computer science engineers are generally dealing with very complex and large scale problems. So mathematical thinking allows them to break down those problems into a small manageable set of problems. That is a first. Secondly, mathematical thinking allows them to make their codes and apps and softwares more efficient. Like they are able to think in terms of computational complexities. If the system becomes large, even larger, so how will they be able to manage it, the number of computations that are going behind the scenes regarding this, and all of those aspects. Thirdly, mathematical logic and reasoning enables them to verify their code, correctness of their code. And lastly, I think it can help them with respect to proofreading of their code, in the sense that at what point or with what input the code might fail or might not work. So these are all the essential mathematical abilities that are helpful in this regard, and I believe mathematical abilities is one of the core aspects that can separate a good computer science engineer from an excellent computer science engineer.
Okay, sir. That makes a connection very clear. So, can you give us a concrete example of an everyday technology that is running on a lot of maths?
Okay, there are so many, but for our aspiring undergraduates or aspiring computer science undergraduates, I would like to specifically mention, like, we are all using Instagram and Snapchat, and we are all using filters in them. Even nowadays, the smartphones cameras have built-in filters in them, like we can make a photo vintage or black and white or vivid or other kind of filters are there. So essentially what happens in the background is that each photo is stored as a matrix in the system, and while we are changing the filter to vivid or to black and white or to gray mode, the millions of pixels are being converted in the background through a mathematical calculation, but it happens in a split second, so we are not able to grasp or appreciate the use of mathematics in all these things. So that happens very instantly. Other examples can be facial recognition systems and Google PageRank algorithm, etc.
So, are there any certain fields in computer science that are more math heavy?
Definitely, ma'am. Generally speaking, the entire computer science domain is reliant on mathematics and is using mathematics in the background in some way or the other. But if we talk about math-heavy computer science domain, what comes immediately to my mind are the machine learning, deep learning, and AI domains, which are using lots of linear algebra, basic calculus, probability, and statistics in the background. Other domains which are heavily dependent on mathematics are blockchain technologies and cryptography, which are used to secure the data. They are using number theory and abstract algebra in the background. So what I can take from this is that particularly in these domains, it is difficult to thrive without having a solid foundation in mathematics.
what do you advise to the students who don't consider themselves as a math person but wants to succeed as in technology?
So this is a common, persistent and recurring query that is in the mind of students, and it is very important to address this. So by being a maths person, we don't mean that student should become a human calculator. What we mean is that he should be able to connect the mathematical concepts, visualize them and connect them with the coding problems that they are solving. And I think for this particular thing, us as educators also have a responsibility that we should be able to make the students visualize those mathematical concepts in practice and everything. So it's not about becoming a math person, it's about more of an intuitive thing, that being able to relate the mathematical concepts with the actual computer science problems that they are solving.
So thank you so much, Agush sir, for sharing the insightful knowledge about the role of mathematics in computer science and engineering. I hope our listeners have learned a lot. Thank you, everyone.